Section 8.3b, finding the sum of a finite geometric sequence or series. In this section, make sure you are paying attention to whether it is a finite or infinite sequence, because you will have a different formula depending on the type of series that you are trying to find the sum of. If it is a finite geometric sequence, here is the formula that you will be using. Three things you need to know. You need to know a of 1, which remember is the first term of the sequence. You need to know r, which is the common ratio. Remember, that's what we multiply each term by to get the next one. And you need to know n, the number of terms that you are finding the sum of. If you know those three things, simply go to the formula, plug in, and there is your sum. First example, find this sum. First of all, recognize that it is finite, because it stops at the 12th term. So we're summing up through term 1 up through term 12. If we were to write this out without the summation notation, this is what our sequence would look like. And so on all the way up through that last term, which would be 4 times 0.3 to the 12th power. That's the nice thing about summation notation, is it's much shorter and much more compact to be able to write in summation notation. Three things we need to know for our formula. First term, do we know the first term? Yes, it's 4 times 0.3 to the first power, which is 1.2. Do we know the common ratio? What are we multiplying by each time? We're multiplying each term by 0.3. Do I know how many terms we are adding together? Yes, we are adding 12 together, so we should be able to go right to the formula. Sum of those first 12 terms is 1.2 times 1 minus the common ratio to the n power over 1 minus the common ratio. From here, plug that whole expression into your calculator. Let's take a look at that. We're going to have 1.2 times, we need a set of parentheses for everything, and then a second set just for the numerator, which is 1 minus 0.3 raised to the 12th power, divided by another set of parentheses for the denominator, 1 minus 0.3. Close the entire thing as well. There's our sum, 1.714. That's the formula you will use anytime it is a finite geometric series. If it is an infinite geometric series, first recognize that it's infinite. Second, you need to look at the common ratio. If the absolute value of the common ratio is less than 1, then there's the formula you are going to use to find the sum. All you need to know is the first term and the common ratio. If the common ratio of the infinite series absolute value is greater than 1, then there is no sum. So looking at number 6 here, find the first 6 partial sums. Now this is different from what we did with arithmetic, where we just simply were asked to find the 6th partial sum, and we found the sum of the first 6 terms. This wants us to find all of the first 6 partial sums. So we went on the sum of the first term, sum of the first 2 terms, sum of the first 3 terms, sum of the first 4 terms, sum of the first 5 terms, and sum of the first 6 terms. This is an infinite sequence because it goes up to infinity for the upper bound. What our terms would look like is 4 times 0.6 to the 0 power, 4 times 0.6 to the first power, 4 times 0.6 squared, and so on, all the way out to infinity if we're going to write all that out. We want to find the first 6 partial sums. First partial sum. What is the first term? 4 times 0.6 to the 0 is just 4 times 1. There's the sum of the first term. We want to know the sum of the first 2 terms. So take that first term, add to it the second term. That's what's going to be the sum of the first 2. Sum of the first 3 terms. Take the first term plus the second term plus the third term, and so on. This can also be done on the calculator. So let's take a look at it on there. Back into your list menu. Operations. Command number 6 is cumulative sum. Into your list menu again. Operations again, cumulative sum of the sequence. Now put that sequence into your calculator. 4 times 0.6 raised to the x minus 1 power, comma, in terms of x, comma, lower bound, comma, upper bound. We want to know the first 6 sums. Hit equals, there's the sum of the first term, 4, which is what we knew. 6.4 is the sum of the first 2 terms. 7.84 is the sum of the first 3 terms. And if you use your right arrow, you can get all of the first 6 partial sums. So let's go back and record those. Sum of the first term we already knew was 4. Sum of the first 2 terms from the calculator is 6.4, 7.84, 8.704, 9.2224, and 9.53344. Part B, find the entire sum. Well, first thing we need to do is decide whether there is an entire sum. What is our common ratio here? Our common ratio is what we multiply by each time. In this case, we're going to multiply by 0.6 every time. Absolute value of 0.6 is less than 1, so we know that there is indeed a sum. Sum of an infinite sequence is the first term over 1 minus the common ratio. First term is 4. Common ratio is 0.6. Plug that into your calculator. The entire sum will converge to 10. Number 7, find this sum. First of all, we need to figure out what the common ratio is. What are we multiplying by each time to get the next term? Our common ratio is 0.1. Our first term is 3. Absolute value of our common ratio is less than 1. Therefore, there is a sum. Sum is the first term over 1 minus the common ratio. Plug that into your calculator. You get 3 1/3 or 10/3.